filling the container with steam pushes out the air. But if the vessel is sealed while it's still hot and then allowed to cool, the steam condenses and the internal pressure drops, meaning the now much greater external pressure pushes in on the surface. And that's bad news for the can.
Oh, there we go. There we go. Oh, it's actively moving. Look at that. I'm doing this with my mind. In case you were wondering, this is all telekinesis.
Mind games aside, the scientific principle is clearly sound. Now, it's just a question of scale.
We're going to ramp things up quite a bit to this 55-gallon drum, which not only has steel walls that are many times thicker, but also structurally it's much stronger because it's round and it's got these ribs. So it'll present much more of a challenge.
All right, now we just wait for it to boil.
For this first test, we're just going to heat the water up until it's boiling vigorously. Then we'll seal it up, turn off the heat, let it cool, stand back and see what happens.
Sealing it up. There we go.
Now that it's sealed, a pressure differential can develop, and the wait begins for the steam to cool and condense.
That kind of makes me nervous.
If this sturdy steel barrel collapses, confidence will be high that the full-scale tank car can also crumple.
How long did it take the little cans to crush?
Those crushed very, very quickly.
I'd imagine they're not structurally near as strong.
No. I think it's going to be one big catastrophic kind of funk. It's going to sound like hitting it with a baseball bat. Oh! What's really cool about this is we heard a couple of bings and bunks at the beginning. This is killing me. But right now, this thing hasn't made any noise in 15 minutes. But what I know is happening inside there is that it's cooling, and that steam is reverting back to water, and it's creating low pressure in there, which is pulling the sides in. They're resisting that because of their structural integrity, but at a certain point, I expect the outside casing to fail, and it should be pretty spectacular. Next time we hold the camera up with magnet. Oh!
There you go.
Wow!
You could feel that.
Woo! That was so cool.
I could feel that in my chest.
Yeah, well, I'm not
weird.
sure if that's just my heart leaping out of my throat because of the... That was amazing.
It was a nerve-shredding display of power.
Wow!
And an ominous sign of the full-scale potential. But Adam isn't ready to move on. Before they can tackle the supersized tank car, he wants to know exactly how much negative pressure they're dealing with.
This time we're going to do the same test again, but we're going to have a vacuum pressure gauge attached so that we can actually monitor what that pressure is. We will also be timing how long it takes to cool down and monitoring the temperature with an external thermocouple. That's a fancy way of saying thermometer. All right, it's bouncing between 193, 195. We'll be logging all of this data as this thing cools down, builds its negative pressure. Okay, timing starts now. And the vacuum gauge is already moving. That's awesome. And eventually crushes, in the hopes that we'll be able to apply what we learn here to a full-size thing eventually.